A 25 cubic centimeter volume of aqueous copper sulfate solution is electrolyzed using two platinum electrodes. The current during the electrolysis was kept at 1 times 10 to the negative 2 amperes, and it took 9.65 seconds to deposit all the copper 2 plus ions as copper on the cathode. What is the concentration of copper 2 plus ions in the solution? Faraday constant equals 96,500 coulomb. This is an electrolytic cell. During this electrolysis process, aqueous copper sulfate electrolyzed using platinum electrodes. This solution contains copper 2 plus ions, sulfate ions, and water molecules. In these electrolytic cells, negative ions attracted towards the positive anode, while the positive ions attracted towards the negative cathode. Always, oxidation takes place at the anode, while the reduction takes place at the cathode. The current during the electrolysis was kept at 1 times 10 to the negative 2 amperes, and it took 9.65 seconds to deposit all the copper 2 plus ions as copper on the cathode. Therefore, at the end of this electrolysis process, all copper 2 plus ions deposited on the cathode as solid copper. First, we will calculate the charge associated with this electrolysis process. Charge equals IT. Current is 1 times 10 to the negative 2 amperes, and the time is 9.65 seconds. The charge involved in this electrolysis process is 9.65 times 10 to the negative 2 coulomb. Faraday constant is 96,500 coulombs per mole. That means amount of electrons that has 96,500 coulomb is 1 moles. Therefore, we will calculate amount of electrons that has the charge 9.65 times 10 to the negative 2 coulomb. Therefore, the number of electrons that has the charge 9.65 times 10 to the negative 2 coulomb is 1 divided by 96,500 times 9.65 times 10 to the negative 2. The answer is 1 times 10 to the negative 6 moles. This is the number of electrons involved in this reduction process. This is the reduction half equation. If the number of moles of electrons involved in the reduction process is x moles, the number of moles of copper 2 plus ions is x divided by 2. The number of moles of electrons involved in the reduction process is 1 times 10 to the negative 6 moles. Therefore, the number of aqueous copper 2 plus ions is 1 times 10 to the negative 6 divided by 2 moles. Concentration is number of moles divided by volume. Therefore, the concentration of aqueous copper 2 plus ions is number of moles, that is 1 times 10 to the negative 6 divided by 2 divided by the volume. Volume is 25 cubic centimeters. We have to convert cubic centimeters into cubic decimeters. The concentration of aqueous copper 2 plus ions is 2 times 10 to the negative 5 moles per cubic decimeter. Answer is number 2.